The next time you're at a railway station or see a train speeding by, take a moment to glance at the ground under the tracks. You'll spot the same thing everywhere. Countless rough, gray, sharp-edged stones spread out along the rails. This holds true whether you're in Asia, Europe, or North America. Those stones are always present. So why do we build our modern high-speed rail systems on what looks like a loose heap of rocks? Why not simply fasten the rails onto a firm concrete base? The reason goes beyond just cost. It's smart engineering that keeps the trains safe and prevents the entire system from sinking into the soil. Plus, it has an unexpected link to old sailing vessels. Welcome to Unwrap the Facts, where we reveal the hidden stories behind everyday things. Today, let's explore the real purpose of those railway stones, officially called track ballast. First, consider the challenge. A fully loaded freight or passenger train weighs an enormous amount, often millions of pounds. If that weight pressed straight down on the earth through the rails and supports, it would quickly compact and damage the soil, causing the tracks to sink, shift, or buckle, which could lead to serious derailments. That's exactly why ballast exists. Picture the track structure like a layered foundation. Steel rails rest on wooden or concrete cross ties, also known as sleepers, and those ties sit on a deep bed of stones. The ballast layer absorbs and distributes that huge downward force across a much larger surface area, reducing pressure on the subgrade soil so it doesn't get crushed or deformed. Here's something interesting. The tracks aren't rigidly anchored deep into the ground. They're essentially floating on this stone bed. The combination of the ballast's weight and friction between the stones and ties keeps everything aligned. This setup also provides a bit of give, letting the track flex slightly under the train's vibrations and dynamic loads instead of cracking or breaking from rigid stress. You might wonder why the stones have to be so rough and pointy. If you grabbed one, it'd feel sharp and uncomfortable, definitely not smooth river rocks. There's a clear reason for that. Smooth, rounded stones would behave like ball bearings. Under the constant shaking and movement of passing trains, they'd roll and shift easily, letting the track drift out of alignment. Instead, railways use crushed rock, typically hard materials like granite, basalt, or quartzite, broken into irregular, angular pieces. When packed tightly, these jagged edges grip and lock together, forming a stable, interlocked mass. It resists lateral sliding, even around curves at high speeds, while still offering enough flexibility to handle vibrations. Beyond holding everything steady, ballast tackles two major long-term threats: water and plant growth. On bare soil or a solid concrete slab, rainwater can create big issues. Soil turns to soft mud and erodes, undermining support. Concrete can trap water, leading to pooling that corrodes metal components. But a deep layer of loose stones acts like a natural filter drain. Rainwater passes straight through the gaps between rocks and drains away quickly, keeping the foundation dry and firm. The track bed is often shaped with a slight slope to guide water outward. As for vegetation, you almost never see thick weeds or grass sprouting right between the rails. The dense, sharp stone layer makes it almost impossible for seeds to settle or roots to penetrate deeply. Without plants taking hold, there's no risk of roots loosening the soil or disrupting stability. Finally, a fun historical tidbit. Where does the term ballast come from? It originated at sea. Back in the days of wooden sailing ships, vessels often sailed empty one way to collect cargo. Without weight in the hold, they'd be unstable and bob dangerously in rough seas. Sailors loaded heavy stones, called ballast, to add stability and keep the ship properly balanced. Upon arrival, they'd unload those stones on shore before filling up with goods. Early railway builders in the 19th century needed an affordable, heavy material to weigh down and stabilize their new tracks. They noticed these discarded ship ballast piles along ports and coastlines, perfect crushed or broken stone. They adopted it for railroads, and the nautical name carried over. So those jagged stones aren't random rubble. They're a clever, multi-purpose engineering solution, distributing weight, draining water, blocking weeds, absorbing shocks, and holding tracks steady, all while being cost-effective and durable for over 2 centuries. Next time you pass a railway line, you'll see those stones in a whole new light. They're a quiet engineering masterpiece keeping global transport running smoothly. This is Unwrap the Facts. If you found this interesting, give it a thumbs up, subscribe, and turn on notifications for more hidden facts revealed. Thanks for watching.